Today we're going to take the limits of log and exponential functions. So let's start with the limit as x approaches infinity of e to the x. So we know what that graph looks like. That looks something like this. The x. Now notice that as x approaches infinity, if we were to follow along the function, as x gets really, really large, our function values also continue to get really, really large. So we can say that this limit is equal to infinity. Now we can also look at this from the other direction, heading towards negative infinity. So if we were to follow along our function, as our x values go to negative infinity, you'll see that we're getting closer and closer to our asymptote of the x-axis. So what this means is that as x goes to negative infinity, our function e to the x is getting closer and closer to 0. So what if we're not given the graph? Let's say we wanted to find the limit as x approaches infinity of e to the 3x. We can reason this out without the use of a graph. Now, if x is getting infinitely large, we know that 3x is also getting infinitely large. So e to a power that's infinitely large would also be going towards infinity. Or maybe our limit as x goes to infinity, let's say our function is e to the negative 3x. We can really think of this as 1 over e to the 3x using our rules of exponents. And now what we still have is an exponent that's getting infinitely large here, right? 3 times infinitely large numbers is still very large. And e to very large numbers is very large. I'm going to make a note of that this is large here. But 1 over a large number is a very small number. And as our denominator gets larger, our fraction gets closer and closer to 0. So now let's think about our log function. Let's say we wanted the limit as x approaches infinity of the natural log. So this graph looks something like this, where the y-axis is now our asymptote. So as x gets infinitely large, our function values continue to get large. Not as quickly as an exponential function, but this limit is still going to be positive infinity. So now let's take a look at the limit, as x approaches 0 from the right. So this function here, if we're coming from the right, approaching x equals 0, our function values continue to decrease here. Our asymptote is the y-axis. So our x values get closer to the y-axis, and our function values are going towards negative infinity. So again, what happens if we're not looking at a graph? We can reason these out. So for example, let's say we have the limit as x approaches infinity of the ln of 4x. Now we know that x is getting infinitely large, so 4x is getting infinitely large, so this here, this whole function, is also getting infinitely large. So we can say that this goes to infinity. Or maybe we have the limit as x approaches 0 from the right of negative ln x. Now we know our transformations of functions, and we know that this means that our function is reflected over the x-axis. So this graph is now going to look something like this, and as x approaches 0 from the right, now instead of going to negative infinity, we're heading to positive infinity.